All right, now that we've figured out how to calculate these rate orders, I just want to reiterate what they mean and kind of why they are useful. So once you figure out this rate law, you can figure out what happens to the rate when you change these concentrations. So let's take a look at example. What happens when you triple the concentration of A? Well, we take a look at the A, we substitute in a 3 here, and so 3 to the -1 is actually 1/3. So the rate is only 1/3 of what it normally was, and so your reaction actually slows down. So if you want to make this reaction go fast, you might think, let's just make everything super concentrated, but you can see you'd actually be doing the opposite of what you want to happen if you try to increase the concentration of A, thinking it'll go faster, because it's going to go slower. What happens when you triple B? Well, we just put in a 3 here. The exponent here is 1 because it's left there, so it's 3 times faster, right? So that would make the reaction faster. What happens when you triple C? Now we put in 3 squared, right? 3 squared is 9, so we'll go 9 times faster now. What happens if you triple D? Well, D, we don't see it anywhere. So what we kind of assume here is that it's there, but then the exponent is 0, right? So 3 to the 0 is still equal to 1, and so nothing happens. And so a big part of chemistry is making reactions either go faster or slower. If you've seen the news, every now and then you'll see a chemical explosion or like a chemical plant exploding. The most common cause of this is basically it's an exothermic reaction, so it's releasing heat. And so they do these in these giant cylinders where they're kind of water cooled, so they're absorbing that heat away. Well, when the reaction goes really, really fast, it's going to produce a lot of heat, and sometimes that heat produced outweighs how much heat they can remove through the water cooling. And so you have an increase in a buildup of heat in an enclosed container, and then it goes boom. So it is very important to know the kinetics of chemistry.